So 2, 2, let me go with a different color. So 2, 2 is here, 5, 2, 5, 5, and 2, 5. And my board is off because people were just walking by, so I'm sorry. So when I connect those up, I know that I've got the distance between them. It's going to be 3 sections on each one, so that's going to be 12 units. So 12 units in perimeter, and the area is going to be, so it's got 3 here, and we've got 3 here, so the area is going to be 9. Let me pause really fast because I got to fix my board. Everybody just came back from the Special Olympics send-off, so my board is needs to be adjusted. All right, so thanks for bearing with me. All right, next problem. All right, so this time we're graphing the following and we're just finding the area. All right. So we have 1, -5, so 1, -5, 4, -7, 6, -5. Let's see if I can fix that point. 5, -2, and 2, -2. So when we connect those points, we have a pentagon type figure. And what I wanted you to do was to section it off. And so if we divide it here, we have a trapezoid and a triangle now. Okay? And when we figure that out, so the trapezoid is, I need to fix my board, I apologize. Hopefully this time we'll do the charm. Okay, so with the trapezoid, again, we're dealing with the bases and then to multiply by height and then dividing by 2. So 1, 2, 3, 4, 5. My bases are 5 and 3. Okay, and the height is 2. So we have 8 times 2 is 16 divided by 2. So that's going to be 8 for the top section. And then we're going to have the bottom, which is so 1, 2, 3, 4, 5. 5 times 3. I think I may have gotten my grading off a little bit. So it's 5 times 2, sorry. 5 times 2, and then divide by 2. Actually, let me fix it because I'm like afraid my dots have messed up. I apologize. All right, so 1, -5, 4, -7, 6, -5, 5, -2, and 2, -2. Okay, so again, 1, -5, 4, -7, 6, -5, 5, -2. Okay, so when I connect that, okay, so I've got 5 and 3, and my height is 3. I think I messed that up last time. The height is 3 and not 2. Okay, sorry about it. I really apologize. So 15 times 3 is 40, sorry, long day. 8 times 3 is 24 divided by 2, and that's going to be 12. And then my triangle is going to be the 5 times 2 divided by 2. So that's going to be 10 divided by 2 is 5. So the final answer is going to be 17 square units. So I'm really sorry about that. All right. Let me clear that one. Okay. All right, next one is graph the figure ABCD with the following vertices. Okay, so we have -4, 3, 6, 3, 6, -2, and -4, -2. So we have a rectangle here. And then it says, so that's this part here. This is a triangle should be drawn into the figure at 1, 3, so over 1 up 3. And then we're going to connect the points. So this is like the one we did on the study guide. So we're going to connect from here to here. And then this is the figure we're referring to. This is the triangle. Okay? So this is find the area of the rectangle. So this is going to be 5. So this is going to be 5 times 10, which would be 50 square units. Then it says find the area of the triangle. So again, 10 is still the base, and the height is 5, but we have to divide by 2 because it's a triangle. So it's going to be 50 divided by 2, which is 25 square units. Then it says find the area of the rectangle that is not taken up by the triangle. By the triangle we shaded, like the study guide questions. This is going to be 50 minus 25. So it's going to be 25 square units. So basically, this section right here is 25 square units. All right, last question for each group. The first group is which is larger, a rectangle with an area of 10 square inches or a rectangle with an area of 40 square centimeters. I basically gave credit. So think about a rectangle. And that's if the area is 10 square inches, and that means that maybe dimensions were 2 inches and 5 inches. The other rectangle is 40 square centimeters. So to get 40 square centimeters, I could have done 4 and 10. So 4 centimeters and 10 centimeters. Well, a lot of you got your conversion wrong. Remember, with inches and centimeters, there are 2.5 centimeters roughly in 1 inch. That's the one we've been using as a standard this year. So that means that when I convert my numbers, I'm going to convert my dimensions here. So this is going to be, let's see here. So 2.5 times, clear. Okay, so 2.5 times 2, which means there's going to be 5 centimeters here, and then 5 times 2.5. And this is going to be 12.5 centimeters. So when I do 12.5 times 5, I get 62.5 square centimeters. You could have also converted the centimeters into inches. Whichever way, it's going to come up to the same answer, that this one is your larger value. Okay, so the 10 square inches. A lot of people were saying there are 10 centimeters in an inch, and that's not right. This is your conversion. Now, for the last question, this is for Math 6 Plus. This one was for Math 6. A radio tower services a 10-mile radius. You stop your car 4 miles east and 9 miles north of the tower. Will you be able to receive the radio waves? So the way I solved this problem is I drew a coordinate plane, and I figured that if my car is 4 miles east, I literally went, if my car started off in the middle, So 1, 2, 3, 4. My car was here and then 9 miles north. So if my car was at 4, over 4 and up 9, was here, then the radius of the signal was 10, so which means over 10 and up 10. So basically the service is something to the effect of where we are, and it's just going to, it will make the service tower, you will get signal. And some of you did indicate that while it will be a signal, it might be a light signal because you're on the very edge of it. A lot of people added the numbers together, 4 and 9, and got 13, and that's why you said it was not going to be reading it, because you added and went outside of the circle, but really it's 2 coordinates, over 4 and up 9. So that's what I was looking for on this problem.